Hey, this is Roy Mitchell again. I want to tell you a little bit more about these new science standards. As you research these new science standards, you'll see that you'll come up with the term three-dimensional learning a lot. Let me tell you what they're talking about whenever you see that. You've already learned about the science and engineering practices, that these are going to be the basis for many of the standards that are coming out in your classes. This is going to be what students do. That, the practices, along with how students think, cross-cutting, and what students know, the content they're going to kind of combine to help students make sense of things, as Brett Molding would say. So let's take a look at these. You already know a lot about these 8 practices, from using models all the way down to obtaining, evaluating, and communicating information. Let's talk about these cross-cutting concepts. These cross-cutting concepts, patterns, cause and effect, all the way down to energy and matter. You have all these that are across the science disciplines. They're not just earth science, they're not just life science, they're not just physical science. So if you include these concepts in no matter what class you're teaching, it might be something that's a framework in which students can easily remember more concepts. Almost any grade level, they realize that there are patterns, that there are cause and effect to things out in nature. And by utilizing that and not being afraid to get out of the life, earth, or physical science box and discussing these, then that probably helps tie things in. The 4 disciplinary core ideas, you're familiar with 3 of them: physical science, life science, and earth science. They have added engineering in here as well. So all 3 of these go together to help students make sense of things. And notice what this diagram has connecting all 3. They have something called authentic phenomena and problems. Now let me explain what a phenomena is. And before I explain it, this is really something that the state is pushing as a way to teach this. The state is saying that you can combine these 3 best or very well through the use of phenomena. And whenever I had a science workshop with the state about the new standards, they spent about 90% of the time of those 2 days were spent modeling and discussing the teaching of phenomena. So the state does not see this as just one method. They're seeing this as a big method, a big way to use the new standards for student excellence. So let's talk about science phenomena. Science phenomena is something that prompts students to ask questions. In a way, it's kind of like a big hook, except the state is hoping that it's not going to be a big hook that draws them in on one day and you forget about that big hook the rest of the unit. They're hoping that if you use something like these rocks that seem to be sliding for an unknown reason in Death Valley, that you refer back to them throughout the unit as you are trying to solve that mystery. Same thing here with this phenomenon high in the Andes Mountains. This animal that looks like it has an ant on its back. So we want them to be able to go out in the world and make sense of phenomena, says Brett Molding. So by using this as kind of the introductory activity, you are getting them curious, you are having them ask questions, you are trying to prompt them to reason things out. Why this is happening, why that is happening, why that is happening. And throughout the unit you can continue with that. Here's some other examples of phenomena here. That's kind of what you're looking to do with these phenomena, to get them hooked and to be able to refer to it throughout the unit. And the state really thinks this is a pretty good way in which to do things. We as teachers prompt the questions that these phenomena arise. So as we prompt the questions, like why do Cheerios tend to go together in a bowl of milk, as we're prompting the question, it leads to these other things that you need to cover. For example, if your standard has them engage in evidence based on argument, you start with asking questions that have to do with the phenomena, and you will lead up to that. And pretty much all these you can lead up to with these questions that are prompting with with phenomena, and that's kind of what the point is. So, how do you come up with a phenomena, and how do you use it in your classroom? Well, naturally, you start out with the standard. With the standard, you then backtrack to some kind of interesting event that can lead to this desired student outcomes. And you know, sometimes it's not easy to think of a phenomena. Some standards are going to be hard to have a phenomena on, but hopefully there'll be enough compilations of phenomena, not only in the county but in the state and even beyond that, to where hopefully you'll have a little bit you can refer to when you come to a certain standard. But anyway, here's kind of the generalities of it. You present the phenomena at the beginning of the unit and ask why. Here you have this cloud that seems to reach all the way from the ground to the sky. What's going on here? And as students give answers, resist the urge to explain, but you're guiding student discussion. And I know I've been bad at this before in the past, of just explaining it to the student. But think about it. If you do nothing but explain, then they don't have to go through the reasoning out and thinking process. So if we resist the urge to explain everything, then we force them to go through the reasoning process of answering the questions why. I'm not saying you don't answer any questions, but I'm saying realize that you want to prompt their reasoning and gathering information, and I think it just lasts longer, retains with them longer if you do that. Now, as you are discussing this, people are going to come up with some different conclusions. You're not going to get everybody that has the same conclusions about why this ground is going from ground to cloud. This cloud is going from ground to the sky. But don't dismiss reasonable conclusions. If they had good thoughts behind it, it just happens to not be what scientists think it is, you're still not shooting them down. We don't want students to think, hey, I've reasoned, I've gathered information, and then, ooh, it's wrong. But you're kind of still leading them in the right direction. You're not going to not ever tell them what it is, but you want them to go through the process of reasoning out what is happening. And all the time you're promoting student gathering, student reasoning, and drawing conclusions. Now, while you're doing that, there are some good opportunities with the use of a phenomenon. One good opportunity is getting reading and writing components. You know, what you have to do is be able to have them gather information. One way you could gather information is with some kind of experiment. Another way you can have them gather information is to read up on it. Perhaps you can find some kind of article online or find the passage in the book, something where you have them reading and getting more information that can help them make sense of this phenomenon. And naturally, at any point during this, you can have a writing component where you have them write a paragraph, write X number of sentences, perhaps even up to writing a longer number of sentences into an essay, what they think is going on. So I know it's sometimes very hard to get reading and writing into science, but here is an opportunity too. And you know, sometimes you have these standards where that's what you're doing. I mean, if you're communicating information, one way you can communicate information is through writing. So you could theoretically have writing with every single phenomenon that you end up introducing throughout the year. Another one of these engineering science practices is engaging in evidence-based arguments. Oh, this is a very good way to have evidence-based arguments. Chances are good you're not going to have everybody have come to the same conclusion as to why you have clouds like this. So that leads to discussions in the class. What do you think this is? Why do you think that is the case? What is convincing to you guys that are not sure about it? Just that's a good opportunity also if you have that as your as the standard. So at the beginning of the unit is a good time to have the phenomenon like these clouds. Then after you discuss the phenomenon and come up with some possible solutions, then you start the unit, and over however many days you would instruct whatever concept it is that tied to the phenomenon. And ideally you would be able to refer back to the phenomenon throughout. It kind of helps bind it together, I guess you might say. Now let me tell you, there are some I guess you can call them resources to find out more about phenomena. We have a good one in the Georgia Science Teachers Association. That's georgiascienceteacher.org. And you can see through clicking on Georgia Standards of Excellence and then clicking on GSE Phenomena that you really have a page which is all about phenomena. You can see you have articles about what makes a good phenomenon, what's the big deal about phenomena. You have collections here, and I'll talk about this top collection here in just a second. You have articles about developing and using phenomena. Probably they can give you more and better information than I could, and it's a resource that you can go back to periodically. So that's a pretty good resource. And also within that resource, within georgiascienceteacher.org, I forget which thing you have to click, but I did notice that they are starting a science GSE phenomena bank. Now, I looked and saw how many phenomena they had so far, and apparently this has just started recently. There were not that many so far, but you can see how they are trying to organize this. They're trying to have organization with greater, where you can look up a greater course and you can look up the standard and find a phenomenon for that particular standard. And you know, if they're able to get more contributors to this, this could potentially be a great resource. You just go to whatever standard you're teaching and see if there's a phenomenon there, and wow, that could be super, definitely worth bookmarking, just for the hope that that happens in the future. But the page that I have found the most phenomena samples of is this one. It is ngssphenomenon.com. This was one of the things, one of the resources on the Georgia Science Teachers Association page. This is just the very top 3 that happen to be on there, but if I counted correctly, there were 96 phenomena the last time I looked that happen to be on here. And of course, all 96 are not going to apply to what you're teaching, but I bet some of them might. So that's definitely worth bookmarking and going through as you're thinking of the phenomena that you're going to do, that you're going to use to teach the new standards. And just a reminder again, this whole process is not just about steps and procedures. It's engaging. It's having the students engage in science to make sense of their world. I know you have a lot of good things that you currently do in your class. You probably are teaching similar content than you were in the old standards, but we're wanting to have the mindset of us not giving every answer to the student. We're promoting them reasoning things out, and I bet you can take that same content and have them do more cognition on their own. Have them do more cognition on their own. I have been out in schools the last month and a half, I guess, doing examples of using phenomena in the classroom. Let me give you some takeaways that I have from that. I have found that in going through the process of having kids explain what they think is going on, it kind of gives value to their reasoning. They're not the only expert. They're not the only person with opinions in the classroom, and they may come up with some very super opinions. I've had teachers say, wow, they had some good ideas. And in your classroom, chances are good some students will have some really good ideas, and it gives value to each student that has good ideas. This is more student-centered than it appears, just because you know, they're doing a lot of the talking, they're doing a lot of the thinking, you're just guiding. We already mentioned number 3, lower grade phenomena don't have to have complex solutions. You're looking for the process. I did one in a 3rd grade class, I think it was, about why the moon is locked in a synchronous orbit with the Earth. And the whole concept of lunar friction, which is one of the probable solution that is pretty complex, but the thought processes of them making a model, which is one of their standards, of the moon going around the sun, that was something that was easily covered in there. Prepare your progression so you don't follow down the rabbit trails of things that don't turn out right. And not giving away an answer doesn't always mean not giving away an answer. You're not giving away the big answers, but you are kind of channeling them toward the big answers or what you are doing. So keep in mind, it's the mindset that you want to have with these new standards. Hope you enjoy.